The study of stance and the regulation of balance has important implications on sports and rehabilitation therapy. Postural sway is important for the maintenance of balance and stability, and it can be determined by measuring the change in weight distribution on the foot. A dramatic increase in sway can cause a person to lose balance and result in instability. The addition of oncoming acceleration coming in contact with the body could further disrupt the balance of the body. This disruption can be countered by a proper stance that provides maximum stability and decreases sway. For this project, 3 different stances were investigated for the difference in weight distribution before and after an accelerating object came in contact with the subject. There was the upright position, the semi-squat position, and the tiptoe position. These are common stances in sports as well as rehabilitation exercises. The null hypothesis states that the 3 stances will statistically produce no difference in stability. In this study, Wii Fit board and LabVIEW were used for data collection. A pendulum was created to standardize the impact force on subjects. The pendulum was made from a supportive beam, a hook, and string, and utilized a gallon of water as its weight. A stencil was made to standardize the semi-squat to ensure all subjects were squatting at a similar angle. Prior to testing, the subject's height and weight were recorded for reference. 6 tests with 2 trials each were done on each subject. The 3 stances were evaluated with the pendulum released from a 45-degree angle. The subjects were expected to catch the approaching pendulum and hold on to the weight until the test is finished. This was then repeated with the pendulum released from a 90-degree angle for each subject. A total of 10 randomly selected subjects were used for this experiment. T-tests were conducted for the 3 stances within the same degree of angle for pendulum release. The p-values for the pendulum release from 45-degree angle is shown. The p-values for pendulum released from 90-degree angle is also shown. The p-values show that the stances are significantly different from one another except in the case of upright versus squat with the pendulum at 90 degrees. From the resultant p-value, the stability results are shown here. Overall, the data showed that the upright and squat stances are more stable than the tiptoe stance regardless of the pendulum's position. The squat stance was more stable than the upright stance with pendulum at 45 degree but not at 90 degree. The null hypothesis stated that the 3 stances produced no difference in stability. This null hypothesis was rejected. The stances showed significant difference in their ability to provide stability. Furthermore, the team was able to conclude that the upright and squat stances are more stable than the tiptoe position. The results generally followed the team's expectations. The team expected the tiptoe stance to provide the least stability and the squat position to provide the most stability. However, it was unexpected that there was no significant difference between the upright and squat stance when the pendulum is at 90 degrees. The experiment was conducted with caution and efforts were made towards standardization to avoid sampling errors. For example, the semi-squat position was carefully standardized. Nevertheless, the team was not able to standardize the tiptoe position. It was observed that each subject tiptoed at a different height, and this may have influenced their stability. Another flaw of the experimental setup was that not all subjects were able to catch the pendulum in their most comfortable position. The pendulum was optimized for subjects with heights of 5'2" to 5'7". Subjects who were out of this height range may have been at a disadvantage in maintaining their stability because the pendulum was either too low or too high for their height. In conclusion, the null hypothesis was rejected, and the tiptoe position was proven to be the least stable stance. The instability of the tiptoe stance was likely to be caused by an elevated center of gravity. Further investigation is needed to distinguish the difference in stability for upright position and the semi-squat position with the more refined experimental method.